Hello everyone, thank you for attending this mini conference presentation. My name is Chun Sen Wong, a DN student, and today I present my review paper of mathematical modeling and control of dynamic systems. This focuses on two key publications: Kamen's 1963 paper and Kumker's 2013 survey. Let's begin. Here, I provide background. Control of dynamic system depends on mathematical model for prediction and inference. I review Kamen's works on linear description and Klemke's on controllability. This aligns with objectives, analyze statements and methods, compare system types, evaluate advantages. The paper structure includes literature review, problems, methodology, analysis, simulations, conclusion. The aim is to inform engineering control design. Let's move to literature review. Early literature centers on linear systems with state space methods. Kamen contributes axiomatic modeling using differential equations and ranks for controllability. Kumker surveys criteria for various systems, including linear, nonlinear, and stochastic. Comparison: Kama for deterministic linear, Kemka extends to non-deterministic and probabilistic. The advantages are Kamen's simplified the computation. Klemke's versatility for uncertainty. Next will be the problem statements. Kamen's problem involves representing linear systems in state space and achieving minimal realizations from input-output data. Klemke's address controllability for stealing status across classes. Covers deterministic for both. Non-deterministic, like delay the Klemke. Probabilistic, stochastic for Klemke. Comparison. Comments: decompositions versus Klemke's theorems. The advantages are Kamen focus on precise tasks. Klemke focus on robust scenario. Let's move to methodology. I describe the process, extract problems and methods, categorized by type. Kamen's use state space equations and rank checks. Klemke's includes algebra criteria, theorems, stochastic measures. Comparison across deterministic, ranks, non-deterministic approximations. Probabilistic expectation. Simulations use programs on a second-order system with noise for probabilistic. Advantages are Kalman's method is efficient in linear. Kremker's methods are general. Now, let's move to the detailed analysis for Kalman's method. Kalman's problem recognize state variables and transfer functions for minimal realizations. The equation is listed in this slide. It applies to deterministic linear with constant parameters. The limitations are no non-deterministic or probabilistic extensions. However, the advantages are it minimizes the model for filter design and simulations. Let's move to the Kremker's analysis. Kremker's problem. Controllability conditions for state steering. The methods are the ranks for linear theorems for nonlinear delayed expectation for stochastic. It covers deterministic, exact, non-deterministic, approximate, probabilistic, mean square. It's built on Kalman for border classes. The advantages are criteria for uncertain systems like delays or noise. The next slide will describe the method comparison. Kalman scope focus on deterministic linear realization. Kremker's focus on broad verification. Both of them have ranks and decomposition on deterministic. However, for non-deterministic, only Lemke's approximation or delays will focus. In probabilistic side, also only Kremker's measures. The advantages are Kalman's is precise in ideal. Kremker's are robust in real world. The next slide will focus on simulations. The second order system is shown in this slide. Kalman's deterministic rank 2 controllable. Lemke's probabilistic 100 runs with noise. the means matches. The results are deterministic can be predictable, is predictable. Probabilistic is robust with deviations. The discussion is Hammond's method is for ideal case. Lemke's method is for uncertainties. To summarize, papers progress for deterministic modeling to verticalize controllability. Objective met through analysis, comparison, advantages. The insights are Hammond's method is efficient. Lemke's method is for general cases. Simulations are validated. For future, machine learning should adopt both methods. Finally, let's go to the references. Here are the references of both papers. Here is the end of my presentation.